Thank you for having me today, and thanks, Xiaoling, for agreeing to be my translator. So I'm going to talk a little bit about some of the requirements that we got about the EIS architecture and why EIS, why did we do what we did. Okay. So data is exploding, and I think you guys heard about that. A lot of data is being produced every day, and a lot of people, when they talk about data, they imagine things like smart cars or even individual consumer data. But in reality, the data that is being produced in factories is very large, and it's going to get larger and larger because there are so many use cases and optimizations that can happen in factories. We were very motivated in EIS by these numbers, by how much data is needed and how much data is being produced in factories. And everybody's excited about analytics and AI for a good reason. You should be very excited about that. But there are a lot of challenges when you have that much data. These are challenges that are very different than what happens in the cloud. And that is why we started looking at EIS. This is why we came up with these concepts of creating distributed data management and analytics at the edge. It's because of the amount of data that is being produced. And it became really not feasible to move the data the way people move it to the cloud today in other industries. So a lot of the data processing needs to happen at the edge. And even though I didn't understand everything Xiaoling said, but I think he made a really good case of putting the cameras at the edge and describing how it works, how the data pipeline works through EIS. And that is very essential, being able to capture that data and act on it at the edge. The amount of data is really, really big, and it's not feasible to move it all to one central location. And that was a huge motivation for us for EIS. In ISD, so Reggie and I, we work in ISD, Industrial Solutions Division in IOTG, and our focus is not just industrial, but we look at those 4 segments. So the first one is manufacturing, and efficiency and throughput are very important in this market. In the second market, it's energy, and again, there's a lot of efficiency use cases there, and how artificial intelligence can help buildings. I believe you heard about the optimizations that can happen in buildings, and logistics is another one. When you start moving processes and data across multiple dynamic geographical locations. I'm going to pause it.
这样的就是说，从这2页我们可以看得到，因为现在的应用场景其实很多。那以前的话是说我们没有数据，现在是有很多数据，尤其是大量的数据、天量的数据。那这些数据的话，如果说我们都放到云端去处理，当然可以，但是这样的效率会很低，而且成本会很高。那么这是为什么我们要引入 EIS 这么一个方案，让它在边缘端去完成数据的一个分析和处理。这样的话，那个上到云端的数量会大大减小。然后我们这个可以应用在这个行业，我们可以看得到，在工业里面、能源里面。然后那个智能楼宇，然后那个交通或者是那个运输，都是可以用到的。
So we have 2 stacks actually that we are producing. The control stack, which is industrial edge controls, is still a work in progress, and it will be out later this year. We, however, are leading with insights and analytics because there are so many use cases that require this kind of stack. And we'll talk. I'm going to share with you some information that we have developed in a pilot that we did with one of our partners that is running today on their factory floor, and the kind of optimizations that we did. But you'll see as well that really, in order to reach autonomous factories and Industry 4.0 and the next revolution in factories, then we need both stacks. We need to be able to control the machines, read the data. And we're going to talk about a little bit of how the data can come from machine data as well as video. And they both will converge into our stack, into EIS, that can send back information to the machine and close that loop.
那我们现在有一些 pilot 的那个就是一些客户一些合作的项目，那我们在里面的话用到了 EIS， 那我们可以把那个现场的数据采出来，采完之后可以再把这些数据反馈回去，或者是控制现场的一些设备。
So why is EIS special? Why is it different than the way the industry today moves data and deals with data? On the right-hand side, you will see a SCADA, a traditional SCADA-based system. These are the systems that have been around for industrial and factories for a very long time. And you'll see that there are some hierarchies, right? You start with devices that are doing the control, and then the data and the flow goes up and down, and you have things like SCADA server and the historian, and then you'll have your real-time and enterprise systems. This is a very traditional view of factories, and it has been around for a long time. And some factories have completely adopted it, others are not, depending on where they are on the industrial scale. On the right-hand side is this revolution that is happening today in factories and industrial. And as you see, the big difference between the two is we're no longer talking about one use case. If you think about historian, it's really one use case. We're rather thinking about it from a very holistic perspective, and it becomes a big data kind of a use case. And the big data, it's basically opening the door for so many use cases that factories could look at. And we have seen some factories where they start perhaps with predictive maintenance or anomaly detection, but then they move on to add more smartness the more they have access to their data. So what we're trying to do is help you and factories and your customers unleash their data and be able to think about all of their use cases that they can build on top. The other important thing that is very obvious here, and is not available there, is that your edge in traditional systems is not a smart edge. It's an edge that is very, very specialized, does one task, and does it really well, but only one task. And as we move compute to the edge, this edge compute that we've heard many of the previous presenters talk about, really moving to smartness closer and closer to the devices. And that could be by putting a camera, or it could be by interfacing to a machine and getting to that data and adding algorithms.
我们提出这两个图可以看到，就是传统的那个 SCADA 系统的话呢，它会有这样一个层级，然后它基本上是单任务的，它就做这么一件事情，而且它抓到的数据的话，更多的是做一个历史数据的追溯，或者说是一些分析。那这个数据的话，可能更多的是一些点数据。那对于我们来说，我们英特片在这个行业里面在打造的这么一套方案的话呢，那它会基于大数据。那大数据是什么呢？除了以前的这种点数据以外的话，我们还有图像数据、视频数据等等等等。那这些数据可能它的数据量会比以前大得多，而且它的数据类型会比以前更加丰富。然后的话，那个以前是单线程、单任务，现在是多任务。我们可以在边缘上，我们可以做很多事情，因为我们把这个边缘处理器变得更加强大，我们的平台可以支撑更多的业务类型。啊，包括储备系统，包括其他的，能让我们那个边缘端的系统更加接近对就是现场的一些设备，让我们跟他们的交互，跟他们的一些共同的工作，能够比以前更加的就是更加的积极。以前的话，我们是单向的采集，现在我们除了采集、分析，我还可以把长相去控制等等。
So I want to mention one more thing about this slide. Sorry, Shelly. So another thing that was really important for us in EIS. And the fact that we are addressing industrial solutions is the fact that eventually, and nearly in the future, we need to become a real-time system. Real-time is very important. It's not negotiable. This is not, a web page that you might accessing and it's okay to wait a little bit, or a home system and it's tolerant with a little bit of details, whether you turn the air conditioning now or in 5 minutes. These are real-time applications, and we need some determinism on it. And today, EIS is not real-time, but it will get there really soon, and there are some Intel technologies that will help us support and get there with virtualization and with containers. And that's an important goal for us that we are addressing in the near future.
实时系统的话，对于我们现在的那个供应环境是非常重要的。那现在 EIS 呢，现在主要还是说一个提取和分析的一个过程，控制这一块现在还比较少。那在后续的版本里面，我们2.3、2.5点上会开始加入我们的那个控制系统，然后那个时候我们会把那个实时的那个操作系统和实时的响应的这些功能加进去，包括我们的一些虚拟化的环境，包括我们的一些所谓的就是虚拟机之类的，就是英特尔的技术都可以集成到我们整套 EIS 里面去。
Okay, so let's talk a little bit about what we're trying to achieve. And I believe you heard earlier today about the Intel compute. So this is, our first cornerstone. This is where everything starts, and we have the multi-core systems, we have the GPU, we've optimized the software using OpenVINO and multiple drivers. And these optimizations are things that you would expect from us as Intel. So we start with our hardware, and we understand which recipes of our hardware make sense for which use cases. And that is, we continue to optimize and enable and look at additional assets that we can work with. And Reggie talked a little bit about the platforms, but also about other technologies like memory and FPGA and virtualization that we enable on the platform, or we add to the platform in order to get the best utilization. We move to the right-hand side, and this is where our job is not just taking advantage of all of those pieces that we are putting in the platform. Our job is also providing components with EIS and OpenVINO that will help you accelerate and get faster to the market and solve those use cases. And this is the goal of EIS and OpenVINO, is to be able to help you get faster to those use cases and not have to worry about the plumbing, the pipelines. We're building those pipelines for you so that you can pick and choose and use them as needed. Because at the end of the day, you might care about how you're moving the data, but at the end of the day, your end user does not really care. Your end user wants these optimizations, and they want them as fast as possible, because those are the use cases that are going to help them either save money or make money. So we're keeping that in mind while we are stitching together and putting together these solutions that have hardware and software components to enable you to get to your use cases in your market as fast as possible.
OpenVINO 是一个相对是硬核企业。Intel 的话，我们 Intel 提供各种各样的硬件技术、芯片技术，包括我们的CPU 的内核，我们有 GPU 集成 GPU， 我们有 FPGA， 有我们的VPU， 还有我们的一些memory 的技术等等等等。那这些技术的话，我们可以通过我们 OpenVINO 把它无缝的连接起来。我们可以再让我们的算法，让我们的应用程序在各个不同的硬件核心上面去运行，而且是无缝的、自由切换的，这样子从而提供给我最终用户的话是一个非常好的应用体验，因为它的处理性能和速度都有大大提升。
Alright, so let's talk a little bit more about what are the different components that either we have already enabled or we will enable soon with EIS. And I know that Xiaoling, I was able to see your diagrams, and I know you dug very deep into the data pipeline. But let's talk about, what are the different components and why are we putting them all together? So again, we're looking at all the Intel assets, and that could be, 5G assets, that could be memory, that could be any kind of core or accelerators, in terms of GPUs or FPGA or the NVIDIA's card, and so on and so forth. But on top of that, what are the things that we want to hit? What are the requirements that we got and are pursuing in EIS? Security is a big deal for us. And we are enhancing our security framework in the next version. And we will get to a point where we will enable TPM and TEE. And that would help you with provisioning of new devices. That can also help you with being able to provide some customers with sandbox when they deploy their data and their analytics that cannot peek outside into other data streams, and nobody can peek into that data. So we've heard a lot of customers talk about some security concerns, and we're trying to address those with both software and hardware components. Device management is a big one, right? Nobody wants to run to the factory to do a firmware update or an OS update. And we're providing that in the next version of EIS for device management, to be able to allow you to manage multiple devices remotely and provide the right kind of software and updates without having, to get to a factory, maybe it's installed in the ceiling, or I don't know where these boxes could be installed, and being able to do all of those without having to go to challenging places. Orchestration is also a big deal, and it would allow you to get to reliability in factories where you can orchestrate the same components multiple times and reduce the downtime for certain use cases. Storage, whether it's in terms of SSD or different kinds of memory, would basically enable a lot of use cases that require fast data movement, and in certain times, even with zero copy, being able to move the data through the pipeline. So the pipeline that Xiaoling mentioned for video could be executed without actually copying the data, with just handing over a handler that can act on the data. And obviously, for when it comes to data, ingestion and processing are very important. How much data can we ingest depends on what kind of data is coming. But we're trying to optimize for multiple kinds of streams. And I'll share with you a use case that is non-video, just to show you that EIS can support both video and non-video, which you probably are already encountering in factories.
好的，对这一点的话，大家有什么问题？因为我可能就是快速过了，因为在这里边的话，主要是说我们 EIS 能够支持的那个各种功能是干嘛的，包括安全啊、管理啊，然后就是所谓的那个备份啊、那个替换这个然后那个存储啊、处理和输入啊这一块，大家有什么问题的话，我们可以再讲一下。如果没有的话，我们再过去。
Alright, I would like to share with you a use case that we enabled a few months back in a factory, and it is running today in that particular factory on real data, real-time data. So this factory had a line that you can see in here, and the products that they were producing were going through this line. The quality control was an offline process that they did, and there were some defects happening in this product. And they wanted to be able to detect this defect as it's happening. The particular nature of the process does not allow cameras to offer any data that is valuable, because the defect is internal to the product and you cannot see it with a video camera. So what we came up with then is it's a robotics use case as well. They have a lot of robots that exist in their line, and these robots are doing an application, a process on these products. What we discovered is every time that robot is doing an application, the data that it was generating was a JSON file that contained a lot of streams. And those streams we could take and analyze and train models on them. So this is not a video use case, but it is a use case that we have enabled over EIS as well. And that's what we tried to do with EIS. We noticed that there were a lot of systems out there that were either video only or time series only. And the use cases that we're seeing in factories sometimes do combine both, especially when it gets to robotics. So we were able to take that data and train models on it. And then after we took the data, developed the model that reached over 93% accuracy, and the customer is very happy running it on their factory floor today, that will flag items as they are being, they flags the process as it's being applied to the product as either good or bad. We discovered that just like videos, there are some common algos that seem to work really well. And I wanted to share with you guys some of this thinking of these algos that can work. In this case, deep learning won't cut it. Deep learning won't work because the kind of data is time series data, and it is not something that video or deep learning, which is basically a suite of algos that work for video. So it did not work. However, there are some additional algos that we looked at that did really, really well.
这是一个真实的案例，那这是跟国外的客户和德国的客户去合作的。那么在它的产业上面呢，实际上它没有用到就是我们 EIS 没有用到它的那个 video 的功能，它实际上抓的是那个时序数据啊，因为很多都是那个从机器上获得的数据。那这个数据拿到之后的话呢，我们一样可以通过 EIS 这个平台，然后来分析和处理这些那个就是时序数据啊，从而得到说那个就是在实际库里得到93%以上的一个那个准确率的一个判断那个值，所以这个方式这个平台是提供的很多。
So what helped us in figuring out the algos? Obviously, we got a lot of data of this use case, but one important characteristic of industrial is that factories are very structured, right? Unlike when you're trying to classify pictures, for example, if you are, someone in the cloud and trying to classify pictures of dogs versus cats, then you can get a lot of data and the data is random, and something like deep learning can help you really, really well. But when you are trying to characterize a very structured process, a process that, you have A that is followed by B that is followed by C, it's very deterministic, it flows on a line, we realize that there are algos that are structured exactly like that. And these are, for the machine learning experts and people interested in the space of you, these are called rule-based training. And rule-based training could be things like random forests, decision trees, SVMs, KNNs. So these do help you create some clustering and classification when your data is very, very structured. And they lend themselves really nicely into factories and industrial use cases. And our algos were based on some of those rule-based training. Because on a lot of times, factories follow an if-then-else rule. They are very, very rule-driven. And these algos traditionally lend themselves into those use cases.
其实我们可以提供 Intel 有一些算法能力，然后我们除了提供那个视频方面、视觉分析方面的能力外，我们也可以提供说基于那个就是基于规则的一些算法。那我们有很好的经验，用不同的一些模型来处理这样的那个基于规则的一些数据和模型的训练。所以这样的话，那个在这方面我们也可以提供一些参考的，可以帮助到大家。如果大家有这方面的需求，那也可以跟我们联系提出来。
Okay, and then when we moved into the analytics, into actually deploying this algo, then we looked at something that maps nicely to that factory floor, to that specific environment. And we suspect that this mapping is going to be consistent in other factory floors. And if you guys remember a few slides back, where I showed the edge compute, and then that goes into the edge server, and then goes into a big data kind of a structure, you will notice that this maps really nicely here as well. And on the left-hand side, on the right-hand side, you still see this factory floor that I have in here. We have the lines, and then we have the cell levels. And in the cell level, there are often controllers. And these controllers, what we did was we mapped next to them distributed analytics with our algorithm. And then we were able to do that and do the data ingest with EIS. Now, sometimes your data ingest, like you chose in here, is a camera, and you could be using something like Movidius with deep learning. In other cases, your data ingest is more of a node that allows you to read other kinds of data. So in our use case, it was the data coming from the controllers. And that data was going over OPC UA and MQTT. And we could ingest that data into those distributed nodes. And then once we ingest that data, then what we can do is run our analytics. And our analytics could be at the edge, but if the actual analytics, actual model is very compute intensive, we could potentially send the data into a Xeon server that sits a little bit higher than those nodes. Now, when do we do that? When do we send the data to a different level versus when do we run the model at the edge? It depends on a few factors. The first one is a cost factor. If the customer wants to deploy at the edge in here Xeon servers, then great. Then they can run that use case there, and they can run the analytics there. And that is a possibility that we are looking at. The other problem that could happen in factories is sometimes you might have a time constraint, because I could have a piece of analytics, right now it's running here, but let's say this piece of analytics has a time constraint, it needs to send data back to those controllers. Then what would happen in here is the network trip, the round trip on the network might be higher than that time constraint. And in this case, even if we have a TSN on the network, it might not work. So we'll have to move that use case of the analytics closer to the edge. And the point of showing these different examples of compute models is that EIS can help you do either or. You are not tied into one compute model. It's very flexible, and you can run it based on the use case on multiple of those nodes sitting side by side, or on a tiered kind of a deployment model.
是大家可以从这个图上可以看得到，就是说 EIS 的话，我们除了在现有的那个软件上，我们这是单机的分析和部署以外，在我们下一个版本开始，我们可以支持像类似像现在提到的这样子的一个分布式的一个部署。那我们可以在整个那个就是工厂的局域网环境下面去布置各个，就是可以把分析 以及存储等等，都可以放到不同的节点里面去，也就是说不同的电脑或者是不同的那个网关上面去运行，最终构成一个总体的一个大的那个就是一个大的一个那个系统框架啊，因为我们后面就可以这样子去做啊。然后的话呢，我们可以在现场一些那个即时那个现场的一些分析的数据，同时我们也可以放到，因为是在一个网络里面嘛，然后我们可以把它就是如果说是有比较高级或者重要的一个数据，我们可以进到最高层的这个服务器上进行进一步的分析啊。所以这个架构对于 EIS 来说它是很扩展的，并且是可以是分布式的，所以大家在部署的时候是会非常的方便灵活。
And the last family of use cases that I want to bring to your attention is we are seeing a lot of industrial factories that are, bigger than a small operation. So medium to large size factories that are very interested in workload consolidation. So an example of those, you could have somebody who, for example, here have deployed predictive maintenance on these robotics. And these could come in as a separate box. And then they could have also deployed anomaly detection somewhere else in a different cell, perhaps on a different process. Maintaining these different boxes tends to be very expensive and requires a lot of different people and different providers. So what we are also aiming to do with EIS and the Intel platform and the virtualization that Reggie mentioned is to be able to have one device, one box, whether it's at the cell level or at the line level, that you can consolidate all of those use cases in different virtual machines on the same box. And that would allow them to, first of all, deploy this box and maintain this box much more efficiently. But also it would allow them, if they want more reliability, instead of buying 2 boxes, all they have to do is launch 2 VMs of that application. So it is a much more cost effective. It's kind of moving that concept from that is heavily used today in the cloud. Cloud service providers don't buy 2 of each thing. Instead, they over provision, right? 10% or 20%, depending what kind of reliability and redundancy they want to have. And that is more than enough to be able to swap their virtual machines and applications to meet the requirement and KPIs. So that would allow the factories to do the same on the cell level or the line level by consolidating those workloads into boxes that they can maintain and replace much more effectively.
那我们可以在工厂里面不同的机器上面去部署不同的算法，做不同的分析。然后呢，在部署的过程当中，我们其实可以很方便，就是说我们有很多，第一，我们可以把不同的方案我们可以部署到同一台合上去。然后呢，这时候它会去，如果我们有多台在里面的话呢，它会做相互之间的备份啊，就是自动化的，它会去做备份。这样子的话，当一些机器我们去监控的时候，其他机器可以去替代啊。然后那个就是在分布式的这个机制当中的话，所有的这些软件其实我们可以通过远程的方式，我们在中基本上可以直接对下面的分布式进行部署。
That's it for me. Questions?
有什么问题吗？再介绍一下，就是Vita是我们那个美国 ISD， 就是工业能源部门的那个就是解决方案部门的那个高级架构师啊，然后那个他也是Intel内部个人研究那个就是所拥有的专利数据多的一个公司，所以你可以问问题。
All right, thank you for having me again.